Hi and welcome to Concept Based. I'm John Hepworth. This is a Year 11 advanced topic. We're in probability and data in the subtopic probability, which is such a weird name for a subtopic of that topic. But anyway, today's question's a little bit different. I don't really feel like it's a new idea or anything like that, but it's definitely a question that kids in my classroom for years and years. In fact, the whole many years that I've been teaching, the whole 20 years, they just make inefficiencies in questions like this. They get stuck at the start because they have this perception that the question is much harder than what it actually is. And so today what I want to do is explain exactly why it isn't as hard as what it may appear, but then really give you just that link to be like, if I see this thing, I know I need to do that. But it does have a foundation in a concept. So we'll definitely be focusing on that concept as well. So let's look at this question. If two six-sided dice are rolled, what is the probability that the sum of the totals is at least 4? Now, what I did do is just do a little diagram that shows that. So let's just pop that in. So here that is here. Try and make it a little bit bigger for you. So obviously, when you roll two dice, well, not obviously, for some students, if you ask them, hey, what's the most common total of two dice if you rolled them? They wouldn't know that it's 7. But if you have a look here, we've got 7, 7, 7, 7, 7, 7. So there's actually 6 out of 36, or it's a 1 in 6 chance that you can roll a 7, as opposed to, say, rolling a total of 2, which you can only do by rolling 1 and 1. Can only happen once, so it's 1 in 36 chance. So 7's the most likely outcome when rolling two dice. But that's aside from the point. The question being, what is the probability that the sum of the total is at least 4? So if you're a student and you've got no shortcuts or sort of concept-based stuff to do this question, you might literally be building this table in the exam, and then you're going to be going along and counting the squares and going, well, there's 1, 2, 3, 4, 5, 6, and away you go. Now, when you're doing that, you might come to a realization and go, oh, there looks like there's a shorter method here because I'm efficient at counting. And I know that instead of counting all of these things, I could count the things that I don't have. So there's a 3, a 2, and a 3. So there's only 3 totals that I don't need. And there was 36 total, so at least 4 must therefore be 33 out of 36. And it's that type of moment of realization that I'm looking for from you, without having to do this table, because this table is massive. And if you get to the point where you're writing the whole table out and then you're trying to count and then you have a realization that there's a shortcut, that's too late. You've already wasted so much time on that question, which is costing you time for those open-ended questions, later on in the exam. So let's have a look at another way. Another way brings in the idea that we could be using not. So if we said, and we've covered this before, that is really small typing. Let me write. The probability of not A is equal to 1 minus the probability of A. So this is paramount to a lot of things in advanced probability questions. This concept is used over and over and over and over. And in this type of question, that's exactly what we're doing with counting the alternative amounts. So rather than counting the 33 outcomes that was going to be our answer, it's just a case of counting the 3 and removing that probability from the total 1. So why would we think of doing that in this question? And the key is this: the words at least. Wherever you are writing a learning log or a summary or something like that, whenever you see the words at least, your brain has to go straight to this rule. This is a complementary event, because they almost never ask you the at least small part. Like if this question was, what's the probability of rolling at least 35 on dice? Sorry, not 35. We're not multiplying the totals, which you can. Questions can be on multiplied totals. What's the probability of rolling at least 11? Well, then you would have only had 3 to count, 5 and 6, 6 and 5, and 6 and 6. But in the HSC, they never ask that part of the question. They always ask, what's the probability of at least more than just a little bit at the bottom? So it always makes you count a lot if you're using an inefficient strategy. All right. So the fact that we now know that this is the strategy that we want to use, let's see if we can work it out. So the probability that it is at least, so greater than or equal to 4, is 1 minus the probability of it being less than 4. Okay, so if you can get to the point where you can write this as your first step as opposed to the table, then you're going to have massive time savings. Dependent on the question, this part that's just here might take a little bit more thinking. There might be some combinatorics later on in this course, that just might take some understanding of the question, and it might not be as easy as this question, but this question is easy, right? So we know that 1, 1 is giving us 2, 2, 1 is giving us a 3, and 1, 2 is giving us a 3. And they're the only options that are less than 4. So the probability of it being less than 4, and we know that there's 6 by 6 in this grid, is just going to be that the probability of greater than or equal to 4 is equal to 1 minus 3 out of the 12 total. Out of the 36 total. There's 2 mistakes in one question from Mr. Hepworth, which then equals our 33 out of 36, which we would have got from our extremely slow table creation and counting technique. So the words at least, alarm bells have to sound. At least means use the complementary event. It is significantly faster. Do 1 minus the things that are less than it, and you'll be able to answer far, far quicker.